Bats are the second most diverse order of mammals and are found on every continent except Antarctica. They play vital roles in our ecosystems and economies by controlling insect populations, pollinating our crops, and regenerating rainforests, though they may go unnoticed or underappreciated. In contrast, how humanity changes the environment is impossible to ignore. We alter landscapes in ways no other organism has managed, carving our name across the Earth's surface. The Golden Gate Bridge in San Francisco, Palm Islands in Dubai, and pyramids at Giza are all visible from space. But that's not all. Deforestation, monocultures, mining, smog, and pollution are also visible from aboard the ISS. Humans have modified 95% of the Earth's landmass, excluding Antarctica, and these changes are driving an ongoing mass extinction of species. Bats are just one of the victims of our attempted conquest over the natural world. But this conquest has few victors. I've talked about bats before, generally and specifically, and why we should protect them. But what are we protecting them from? The answer mostly is us. Today, we're going to look at the major threats to bats around the world. There are some unique challenges when it comes to bat conservation that are important to talk about before exploring specific threats. Some come down to the nature of bats themselves, and some to human and scientific bias. The life history of bats poses the first challenge when it comes to conservation. Life history is the pattern of survival and reproduction of an organism, along with the traits that directly affect survival and the timing or amount of reproduction, including factors like an organism's growth rate, timing of reproduction, age of sexual maturity, and the size and sex ratio of offspring. Most bats have a slow life history. They live long, reproduce slowly, and have few offspring. Some bat species can live for decades, with pregnancy lasting between 6 weeks and 11 months, and most species give birth to a single infant at a time. Bats also have relatively high metabolic rates and thus high energy requirements. They eat a lot for their size. Due to these factors, bats naturally take a long time to recover from population loss. On to scientific biases. There is a lack of data on bats themselves and a bias in the data that does exist. Over half of the bat species assessed by the IUCN have unknown population trends, including a third of species classified as least concern. Understanding threats and assessing risk levels is difficult when the data just isn't there. Prioritizing conservation efforts is made harder when it's unknown whether a population is increasing, decreasing, or stable. There are also significant geographic biases. Europe and the Americas dominate bat conservation research. Despite equatorial Africa having one of the densest concentrations of bat species in the world, it's one of the least studied regions when it comes to bat conservation. Asia, especially West and Central Asia, are also understudied. In this video, I tried my best to provide examples from all around the world. There is also human bias. Perception of bats vary wildly across the globe. Some cultures view bats as good luck, others as evil entities. Some believe bats are medicinal, others fear they'll bring disease. Effectively enacting change requires understanding and acknowledging cultural biases, how these impact human behavior, and addressing threats in ways that take not only the science of conservation into account, but the social aspects too. Now that we've addressed some of the challenges in bat conservation, it's time to discuss the major threats our flying friends are facing around the world. The threats are listed out separately, but in reality, it's more of a web of interconnected factors that impact one another. Everything is all connected. Habitat loss can lead to persecution, agriculture can cause pollution, bushmeat can spread disease, urbanization can introduce invasives, and climate change impacts everything. As a result, threats will be cross-referenced, though I tried to keep things from being too repetitive. Forests are the most important habitats for bats, supporting both bat abundance and diversity. The greatest concentrations of bat species in the world are found in the tropical forests of equatorial Africa, South America, and Southeast Asia. Many of these species roost in tree cavities or amongst foliage, and it's the primary foraging habitat for many species, whether they feed on insects, fruit, nectar, or other organisms. Land use change is one of the biggest drivers of biodiversity loss worldwide, and the loss and degradation of forests globally is a severe threat to bats. In fact, land use change is considered a more immediate threat to biodiversity in many regions than climate change. The loss of habitat compounds the effects of climate change as well, and other threats. Thus, protecting our forests is crucial to help build resiliency so that bats are able to better tolerate threats long term. So how does forest loss, degradation, and fragmentation affect bat populations in tropical and temperate forests around the world? Currently, tropical rainforests are the biggest priority when it comes to bat conservation. Most research comes from the neotropics, then Southeast Asia, while studies from Africa remain rare. The rate of deforestation in the tropics has been increasing. 20% of rainforests are subjected to some level of timber harvesting, and the result is a mosaic of human-modified habitats, made up of agroforests, agricultural land, tree plantations, logged forests, regenerating secondary growth, and remnants of old growth. One of the impacts of humanity encroaching into forests is a direct loss of roosting and foraging habitat for bats. If there are no trees, there is nowhere to roost for many species. Old-growth trees, both living and dead, provide vital roosting habitat for many bat species, and a loss of this old growth can be devastating, as younger trees may not provide suitable roosts. Frugivorous and nectivorous bats directly lose food when the plants they once fed on disappear, and insectivorous bats suffer when the habitat insects need vanishes. Habitat loss can also lead to more conflict with humans, as species are forced to depend on human-modified habitats for sustenance and shelter. Fruit bats have been documented damaging fruit crops, which can lead to mass killings of bats, sometimes with government support. Bats may also rely more on human structures for shelter, which can lead to entire colonies being exterminated. Even when some habitat remains, the fragmentation of it causes significant issues. Habitat fragmentation occurs when continuous habitat is subdivided into smaller, isolated patches between modified habitats. Large swaths of land converted for agriculture or urban development can separate once connected habitats by tens or hundreds of kilometers. Even relatively narrow barriers like roads or railways can disrupt wildlife, including bats, which we'll cover later in this video. Logging takes many forms, most of which have negative effects on tropical bats. Clear-cutting is the most devastating, where entire forests are felled at once, leaving no remaining habitat. However, selective logging also has a significant effect, occurring in rainforests at 20 times the rate of clear-cutting, and it's often a precursor to it. Selective logging can retain a large proportion of the biodiversity of old-growth forests, but its sustainability depends heavily on harvest intensity and extraction techniques. How many trees are being removed and of what age, size, and species all play a role. It's also important to note that not all bats are affected equally. Depending on the diet and lifestyle of a given species, populations may react positively or negatively to selective logging. On to temperate forests. While less of a conservation concern than the tropics, temperate forests are nonetheless vital habitats for many bat species. Historically, managed timber production in Europe, Australia, and North America used practices that were damaging to bats. Removal of standing dead trees removes valuable roosting sites, and even-aged management, where trees in an area are managed so that they are all the same age and size, change the dynamics of a forest in a way that limits diversity. A mixed-age forest, with trees of various sizes, ages, and species, provides the greatest diversity of habitat, promoting bat abundance and diversity as well. Recently, there have been shifts in management practices that are likely kinder to bats in temperate forests. Managing forests in a way that creates spatial temporal heterogeneity, or a variation in the size, age, and spacing of trees, are likely to benefit bats. However, these practices need to be implemented across regions to be the most effective. One of the most significant land use changes occurring globally is the conversion of land for agriculture. Roughly half of the world's habitable land is used for agriculture, and the ramifications of this are vast. Agriculture is listed as a threat for over half of threatened bat species. Agricultural habitats can be home to considerable bat diversity depending on their arrangement. However, widespread use of pesticides and insect-resistant crop varieties reduces food sources for insectivorous bats. Pesticides directly poison bats as well, particularly organochlorides like DDT, which we'll talk about later. Agricultural areas also provide important foraging habitat for fruit-eating bats, which unfortunately can lead to persecution. Tree plantations in the tropics are an important area for bat conservation. 3 systems dominate here: fast-growing timbers for paper and pulp production, such as acacia and eucalyptus, rubber trees, and oil palms. Bat diversity is lower on plantations than in unlogged forests. Rubber and oil palm plantations in Sumatra only supported a quarter of species richness of nearby forests. The majority of bats and other species were unable to adapt. Not all agricultural methods are the same. Lower intensity methods like organic farming and shaded agroforestry have been shown to support more species richness than more intensive methods. Organic farming uses fewer pesticides under stricter circumstances. helping to maintain healthy insect populations, which 70% of bat species feed on, and reducing the risk of poisoning bats themselves. Shaded agroforestry uses native trees and shrubs interspersed within a crop, creating a canopy cover and improving soil quality. The mix of trees used in agroforestry also provides the right amount and kind of cover to facilitate foraging in different bat species, though this is highly species-specific. Corridors of vegetation between agricultural habitats can help make fragmented regions more accessible to bats, and studies indicate that green corridors are used extensively by bats. Moving on to one of the more direct human causes of bat declines, hunting and collecting. Currently, 178 species are killed for food, medicine, collecting, or persecution. Hunting bats for bushmeat and medicine is widespread in Africa, Asia, the Pacific Islands, and to a lesser extent in Central and South America. At least 55 bat species are hunted in Africa, with frequent bat hunting reported in the Benin Republic, Ghana, Guinea, Liberia, Nigeria, Cameroon, and occasional hunting is reported in Mali and Zambia. At least 64 species are hunted in Asia, mostly in Southeast Asia. Indonesia and the Philippines have the highest rates, though it's widespread in Brunei, Cambodia, East Timor, Laos, PDR, Malaysia, Myanmar, Thailand, and Vietnam. Many bat species are also eaten in China, where they are not specifically protected. 40 species are hunted in Oceania, or a quarter of all Pacific Island species, including in the American Samoa, the Cook Islands and Niue, the Federated States of Micronesia, Fiji, Guam and the Northern Mariana Islands, New Caledonia, Palau, the Solomon Islands, and Vanuatu, where cultures often have a long history of hunting bats. In South America, hunting for bushmeat is uncommon, though there is highly localized hunting of 8 species. In North Africa and West and Central Asia, 5 species are known to be hunted for medicine. Large fruit bats are the most at risk. Half of all theropodid species are hunted. Previously, hunting was not considered a threat, but now all but 5 species have been moved up to a higher threat status. Hunting can also lead to extirpation, the local loss of a species within its historic range. Harvest rates are high and unsustainable based on known population sizes and dynamics, according to the few studies available. The bushmeat trade is mostly local. The Convention on the International Trade in Endangered Species, or CITES, prohibits the trade of theropodid species, and many nations prohibit or restrict importing bat meat, though a black market exists. Bat meat ranges in value depending on the region. In some cases, it's a delicacy enjoyed at special occasions. In other places, it's a street snack, and in others, they're an available protein source when other options are unavailable. Some prefer bushmeat to domestic livestock because of taste and perceived higher nutritional value, and these social and economic influences are vital to addressing conservation. The bushmeat trade provides a source of protein to communities, and the sale of bats provides supplementary income. Simply prohibiting hunting is not an effective solution when people rely on bushmeat to provide for themselves. Thus, ensuring communities have sustainable and reliable sources of income and sustenance is critical to protect bats and other wildlife. The use of bats for bushmeat and medicine may also be deeply entrenched in cultures. Addressing bat hunting in regions where their use holds cultural significance or importance requires not only managing the ecological realities of conservation and educating the public on said issues, but also requires taking cultural practices into account and working with local communities to find solutions that are sustainable and culturally inclusive. The illegal wildlife trade is the 4th largest criminal industry after counterfeiting, drugs, and human trafficking. And this lucrative trade is a significant contributor to the current global extinction crisis. Research into the ornamental animal trade is mainly focused on charismatic and easily identified species, leaving bats under-researched and poorly protected. Harvesting bats for souvenirs, curios, and decoration is a growing concern, particularly with the rise of online marketplaces. Trade is documented for at least 10% of species in the families Rhinolophidae, Hipposideridae, Megadermatidae, and Pteropodidae. However, only 3 genera are named in CITES, which prohibits and controls trade: Pteropus, Acerodon, and Platyrrhinus. A 2024 study by Coleman et al. Assessed the ornamental trade in the bat species Caravula picta, or the painted woolly bat. The researchers found 856 unique bat listings across Etsy, eBay, and Amazon during the study period. 215 of those listings contain at least 284 individual painted bats. In light of this study, eBay, Etsy, and Amazon appear to have pulled any listings containing bat specimens. But private websites still sell bat specimens online, including painted bats, as of the recording of this video. Additionally, data from the U.S. Fish and Wildlife Service Law Enforcement Management Information System lists over 5,500 Caravula specimens seized by authorities between 2000 to 2018. So the trade is likely much larger than Coleman's study was able to verify. Sellers often allude to sustainable harvesting practices, such as captive breeding, using animals that died in the wild, or claiming a species is not at risk. Coleman et al. Refute any such claims of sustainability. Captive breeding of insectivorous bats is not viable, and in the case of the painted bat and many other species, hunting is illegal in many of the range countries. Furthermore, over half of all bat species assessed by the IUCN have unknown population trends, including 35% of species classified as least concerned. It's virtually impossible to know these species are being hunted sustainably when both population trends and hunting rates aren't known. Now, it should be noted that cultures around the world, including many indigenous cultures, harvest bats to use ornamentally for traditional and cultural uses. Selling curios to tourists or online to Americans and Europeans is not a traditional use, and I would argue jeopardizes cultural practices long term. Overharvesting depletes populations, so a desire to sate Western consumerism by commodifying wildlife may deprive future generations of indigenous peoples from partaking in their traditional cultural practices. If you want to learn more about the painted woolly bat and the sustainability of the ornamental trade, I have a video all about that coming out later this week. Subscribe to my channel to make sure you don't miss out. When it comes to hunting and the ornamental trade, bats are killed because they are wanted for some use, whether that's food, medicine, or decor. But bats are also hunted because they are unwanted. They're persecuted because of agricultural damage, disease risk, and cultural beliefs about bats. While some of these concerns are based in truth, mass killings rarely prove to be an effective solution and, in many cases, worsen the problem they were trying to solve. In the paleotropics, fruit bats are persecuted by farmers because of the damage they cause to crops. Bats in these regions are seen as vermin to be exterminated. In some of these regions, local and federal governments encourage mass cullings of bats that damage crops. The African island nation of Mauritius off the coast of Madagascar conducted mass culls of the flying fox species Pteropus niger between 2015 and 2016. The conflict arose because the bats ate fruit crops, primarily lychee. Political and economic barriers in the country limited access to tools like crop netting, which successfully mitigate bat damage in other countries. On top of that, misinformation about the extent of damage caused by bats compared to other sources fueled negative beliefs. The government of Mauritius implemented a cull in October 2015, killing a reported 30,936 bats. A second cull in December 2016 killed another 7,380 individuals. Culling is ineffective and inhumane. Research in Australia found that fruit bats shot often take hours to die, and killing lactating mothers starves pups. The only effective way to prevent damage has been netting crops. Bats are also killed because of fear of disease. Bats are a vector for several deadly viruses, including Ebola, Marburg, Hendra, Nipah, coronaviruses, and rhabdoviruses, including rabies. Spillovers from bats to humans can occur directly via contact with infested bats or indirectly, such as through contaminated goods. In Latin America, most rabies infections in humans and livestock are from one species, Desmodus rotundus, the common vampire bat. To try and reduce rabies incidences, vampire bats are culled in many regions. In Brazil, government programs target vampire bats, which are captured and poisoned or coated with anticoagulants so that multiple bats are killed while grooming each other. Roost sites are also targeted and destroyed with fire or explosives, killing other bat species sharing roosts. Not only are these culls damaging to the bats themselves, but they just don't work. A 2012 study looking at vampire bat culls in Peru found that they not only failed to reduce the prevalence of rabies, they may have actually been counterproductive. Human disturbance affects over a third of bat species and goes beyond hunting and collecting. Caves and other subterranean features, like abandoned mines, are vital bat habitats. They provide roosting environments with relatively stable temperature and humidity, allowing species to hibernate through the colder months. Not only are caves important for bats, bats are important for caves. Some cave systems extend for kilometers. Sunlight hardly penetrates past the entrance. The lack of sunlight means energy and food isn't provided by plants growing within. So these ecosystems are dependent on resources from the outside getting swept or washed into the cave. Bats that roost in caves help with this process with their poop. Bat guano, as covered in a previous video, is rich in nutrients, and some tropical caves depend on the continued deposition of bat guano for nutrients and energy that support the entire ecosystem inside. Human intrusion into these habitats, intentional or not, disturbs bats. Cave tourism began in the late 19th century, and today around 7 million people worldwide visit caves recreationally each year. Developing caves for tourism frequently involves introducing artificial lighting, modifying entrances, and adding paths and parking lots, all of which disturb bats. In addition to habitat challenges caused by the development for tourism, humans themselves disturb bats. Not merely through presence, but through changes in cave temperature, humidity, and carbon dioxide concentrations, all of which can cause bats to abandon their roosts. We also spread harmful diseases to bats, like white nose syndrome, which we'll cover later. The Fourth Chute Cave in Quebec was formerly the largest hibernacula of the eastern small-footed myotis, and after it was developed for tourism, the bat colony abandoned it. Closing caves to the public can be a solution when done right. Catamount Cave is the largest known hibernaculum in Alberta, Canada. 3 species use the cave, the most common being the little brown bat, which I have a short video on. After the Alberta provincial government closed the cave to the public to prevent disease, the number of hibernating bats increased. In 2022, the world's human population surpassed 8 billion people. Today, more than half of those people live in urban areas, and by 2050, it's estimated that 70% of people will live in cities. Urbanization is slowing down in developed countries, but it's increasing in Asia, Africa, Latin America, and the Caribbean, many of which are bat biodiversity hotspots. Urban development is necessary to provide for the human population and improve quality of life, but poses several problems for bats. The threats posed by urbanization to bats are many and complex. The effects of habitat loss mentioned in the segments about logging and agriculture also apply to urban development. Generally, habitat use by bats decreased in urban areas compared to natural areas, although not all species fared equally. Some bat species adapt and seemingly thrive in urban areas. Some of the negative impacts of urbanization include greenhouse gas emissions and pollution, which will be covered in their own segment. For now, I want to focus on 2 interesting effects of urbanization that threaten bats: introduced species and transport corridors. Around the world, millions of species have evolved over billions of years, each one adapting to their environments over generations to better survive in their habitats. It is this abundance and richness of species and the complex web of interactions between them that form ecosystems and sustain human life. However, humans are changing this dynamic. Cities globally are becoming more and more similar to each other. The largest irrigated crop in the US is not found in farmers' fields. It's lawn. Turf grasses make up 2% of the US's land cover, most of these species introduced from Eurasia and Africa. A 2014 study looking at plant diversity across 110 cities in 36 countries found that in cities, a median of 28% of plants are exotic. While cities generally have more native species than non-native species, the introduction and widespread use of non-native plants still has negative effects on a variety of organisms, including bats. Removing or replacing native habitat can endanger food sources bats rely on, and they may not be able to support a healthy ecosystem in the same way native plants do. Insects eaten by bats rely on native plants to survive, and fruit, pollen, and nectar-eating bats depend on local vegetation. Habitat use by bats was lowest in very urbanized areas, think a city's downtown. But habitat use in towns and suburbs was also much lower compared to natural areas, and I think native species play a role. While suburbs and small towns are less urbanized and may have more green space, they often have large amounts of altered habitat with non-native plants. People's lawns, public parks, and ornamental planters are often full of introduced species, possibly reducing available foraging and roosting sites, though there's little information available to support this. Another aspect of urbanization that negatively affects bats are transport corridors, especially roads. A 2016 paper by Jung and Threlfall says, roads destroy, fragment, and degrade habitat, are sources of light, noise, and chemical pollution, and can kill directly through collision with traffic. The negative effects of road on wildlife cannot be refuted, but at the same time, road building and upgrading are seen as important economic drivers. As a consequence, infrastructure projects and protection of bats are often in conflict with each other. Habitat loss occurs during the construction of the road itself And completed roads create barriers between habitats, both nightly between roosts and foraging habitats, and seasonally between summer and winter roosts. And this barrier effect increases with road size and traffic volume. Bats make major detours to avoid roads or find appropriate crossing points, wasting energy and time. Bats that do try to cross often meet untimely ends on roadways. Many species fly slow and low, so they end up crossing at the height of oncoming traffic rather than above it. Even if they manage to avoid colliding with vehicles, bats can be pulled into the slipstream of passing cars, causing mortality. Light and chemical pollution from automobiles are also detrimental to bats. But it's not all bad. Roads are beneficial to some species, and there are ways to build better for our flying friends. Bats are particularly fond of roosting under underpasses and bridges, especially if they're over water or wooded valleys. Constructing bridges and underpasses with a little extra clearance for bats can provide roost sites and safer paths to cross roads at. Additionally, rural roads with hedgerows or trees along the side can serve as valuable wildlife corridors and foraging sites. If managed correctly, roadside verges can be some of the most species-rich habitats in agricultural areas. So while roads do negatively impact bats in many ways, they can also be utilized to help them. Energy production and resource extraction are driving biodiversity loss across taxa and the globe. For bats, two industries stand out that I want to focus on for today: mining and wind energy. Subterranean habitats are critical for the survival of hundreds of bat species globally. Bats use caves, mines, and fortifications for roosting. In North America, 28 out of 45 bat species roost in old mines. In Europe, subterranean fortifications are used extensively by bats. The Maginot Line between France and Germany, built before World War I, and the Nietoperek tunnels in eastern Poland, built during World War II, are both inhabited by bats. Intentional closure or renewed mining can disturb or damage colonies. Some countries, like Australia and the US, have government programs to close abandoned mines and have implemented more bat-friendly practices, like installing bat gates, though the efficacy of these gates varies. In these cases, it's a careful balance between the safety of humans and well-being of wildlife. Inactive mines provide critical habitat. However, mining and quarrying threaten bats by degrading and destroying subterranean and nearby surface habitats. Limestone quarrying for cement production is of particular concern, especially in karst areas. Karst formations are made of limestone and eroded by water, creating landscapes that are abundant in caves, sinkholes, and underground streams. Southeast Asia has the highest annual quarrying rates in the tropics, and these rates are increasing faster than in other regions. Some of Asia's most striking landscapes are karsts, such as Guilin and Wuling Yuan in China, Phang Nga Bay in Thailand, Halong Bay in Vietnam, El Nido in the Philippines, and Vang Vieng in Laos PDR. Karst also forms critical habitat for bats, which roost in abundant caves and fissures. Harvesting limestone from karst formations can result in the total loss of outcrops and consequently bat habitats. More and more, humanity is harvesting the power of wind to meet our energy needs. 8% of global electricity production comes from wind. Wind is a renewable energy source that doesn't emit greenhouse gases when generating electricity. However, while representing a clean energy source, it's not environmentally neutral. Fatalities from collisions with wind turbines are now a leading cause of observed mortality in bats. 9 species are threatened by wind turbines, according to the IUCN. It's estimated that over 500,000 bats are killed annually in Canada and the US, and there are over 300,000 annual deaths in Germany. These mortality rates are high enough to cause rapid population declines and even increase the risk of extinction for some species. Turbines kill bats directly through blunt force trauma, but also indirectly through barotrauma, trauma caused by changes in air pressure around turbines, which can rupture lungs and cause internal bleeding. And these collisions aren't a matter of chance. Bats seem to be attracted to turbines. The exact reason why is still unknown. Some theories are that turbines resemble roosts, or they attract insects, and thus the bats that eat them. In North America and Europe, migratory bats are hurt the most by turbines, with mortality peaking in the autumn during migration season. Globally, fatalities peak at different times depending on the region, and what little research there is outside of North America and Europe suggests that these fatalities are not restricted to migratory species. There are effective and easily implemented strategies to significantly reduce bat mortalities. However, most of this research is based in North America and Europe. Limiting turbine operation during high-risk periods at night during autumn migration can reduce fatalities with minimal impact on power generation. Studies from Germany, Canada, and the US have found that increasing the cut-in speed of turbines, the wind speed at which the blades begin to rotate and generate electricity, can reduce mortalities by at least 50%, and in one study as much as 93%. While these mitigation strategies have been proven effective in research, implementing them has proven challenging. Wind energy is primarily the jurisdiction of municipal and regional governments, so implementing bat-friendly guidelines comes down to local planning commissions, zoning boards, or city councils. Another challenge is that recognizing species as endangered doesn't automatically ensure their protection. In the USA, most species of bats, including migratory tree-roosting species killed most frequently by turbines, are not protected under federal, state, or provincial laws. And documented presence or fatality of species listed as threatened or endangered does not necessarily mandate monitoring or mitigation as one might expect. Rather, all efforts are voluntary, even in cases involving a listed species. Climate change is now recognized as a significant threat to global biodiversity, and its effects could surpass those of land use change by 2070. When it comes to climate change in bats, there is mounting evidence that changing climatic conditions, including extreme weather events such as drought and flooding, are causing shifts in species richness and distribution patterns of biodiversity at an unprecedented rate. Changes in climate can lead to changes in migration, reproduction, and survival rates. Sustained high temperatures above 42 degrees Celsius can cause physiological stress in bats, and has resulted in mass die-offs in flying foxes in South Asia and Australia. And researchers suspect that extreme weather events are affecting other bat species in ways that are harder to observe and quantify. Bats' nature may make them more resilient to some of the effects of climate change. Powered flight grants greater mobility, so species may be able to respond to rapid changes in climate and range. And bats are adaptable, able to use diverse habitats and alter behavior, which may buffer some species from extinction. At the same time, climate change will likely exacerbate other threats to bats, including habitat loss and fragmentation, urbanization, and diseases. If a bat needs to relocate because of rising temperatures and food availability, but most natural habitat has been cleared for agriculture or urban development, species may be left with nowhere suitable. Bat species that otherwise adapted to urban life may no longer be able to survive in warming cities. Climate change is a global problem, but intervention on a local level is critical to protect species. Wetlands and forests absorb carbon dioxide. Protecting and restoring these habitats can make them more resilient to extreme weather events and can provide bats foraging habitats. In semi-arid areas impacted by drought and increasing human demand for water, strategies that focus on restoration of watercourses and provisioning water to wildlife may help. Globalization has hastened the spread of invasive species, which are a major threat to biodiversity globally. The IUCN lists invasives as a threat to 69 bat species. Let's focus now on two of these organisms that pose massive threats to bats. It's a chilly winter day in northern New York State. Biologists with the New York State Department of Environmental Conservation are conducting their annual winter surveys of hibernating bats in caves and mines. What they discover during these routine surveys is anything but. Bats are seen flying out into snowy winter landscapes when they should be hibernating. Inside the cave is even more grim. Instead of cozy colonies cuddling on the ceiling, biologists find heaps of dead bats piling up on the floor of the cave. On the few remaining bats, a white, fuzzy growth is seen on their muzzles, wings, and ears. That was in 2007. At the time, the cause of this catastrophe was a mystery to biologists. But it would mark the beginning of one of the most devastating wildlife epidemics in recorded history. White nose syndrome is a fungal infection decimating bat populations across North America. It emerged in New York State in 2006 and has since been confirmed in 12 species across 7 provinces and 35 states. While white nose syndrome affects a small number of species, its impact on those species is enormous. Mortality rates from white nose syndrome typically range between 70 and 90%, decimating entire colonies. Prior to the emergence of white nose syndrome, all 6 hibernating bat species in the US had positive population growth trends. Now, 4 of these 6 species have suffered severe declines. Pseudogymnoascus destructans is the fungus responsible for white nose syndrome. The disease is seasonal, infecting bats in the fall, spiking in early winter, and peaking in the late winter. It spreads from contact between bats or contaminated roost sites as the fungus is persistent in the environment. Researchers have cultured samples taken from hibernacula in the summer when bats have been absent for months. White nose syndrome infects the skin tissues of bats, including wing and tail membranes. It also causes bats to wake up too frequently from torpor, the reduced state of physiological activity they enter when hibernating. This wastes energy, reduces fat reserves, and causes the bats to starve. They usually die before spring brings warm weather and insects to eat, and before birthing can help replenish the population. While there's been rapid research into white nose syndrome since its discovery, and much more is understood, including how it spreads and harms bats, critical gaps in our knowledge remain, including ways to limit spread or effective treatment options to reduce disease mortality. So where did white nose syndrome come from? P. destructans, which causes the disease, is endemic to Europe. It was most likely introduced to North America by somebody who visited caves in Europe and subsequently visited Howe's Cave in New York with contaminated gear, where the disease was first documented. White nose syndrome is commonly found on European bat species, but it's not associated with mass mortality. It's been confirmed in Austria, Czechia, Belgium, Estonia, France, Germany, Hungary, the Netherlands, Poland, Portugal, Slovakia, Switzerland, Ukraine, and the UK. And there's photo evidence for cases of the disease in Denmark, Luxembourg, Romania, and Turkey. White nose syndrome may also pose a threat elsewhere in the future. Although currently restricted to North America, the pathogen is a potential threat to hibernating bat populations in other parts of the globe, and is a global concern for bats in the Anthropocene. When it comes to combating white nose syndrome, the focus is on monitoring and limiting the spread of disease, as well as helping affected populations recover after. The best thing to do is to keep out of sites where bats are hibernating. Let them rest undisturbed. Closing known hibernacula to the public can help reduce transmission, as was done in Alberta's Catamount Cave. Cavers and researchers should decontaminate gear between trips to reduce risk of cross-contamination. This can be done by submerging your gear in hot water or using chemical disinfectants. Though there is currently no effective, large-scale treatment for white nose syndrome, researchers are working tirelessly to try to find potential options to prevent and treat the disease. Vaccines and probiotics are being developed to help bats fight off illness. The fungus that causes white nose syndrome has some big weaknesses too. It's sensitive to ultraviolet light and has specific temperature requirements. Scientists have used UVC light and antifungal agents to try and sterilize hibernacula. Additionally, researchers have lowered temperatures in roost sites using passive cooling techniques to limit fungal growth. Do you like cats? I like cats. Do you have cats? I just got a couple. Meet Bela and Boris. Do you want to know one of the single most impactful actions you can take to protect local biodiversity, including birds, bats, and other mammals? Keep your cats inside. Free-roaming cats are one of the most destructive invasive species globally. And yes, that's what they are, invasive species. Yes, you too. In the US alone, cats kill an estimated 4 billion birds and 23 billion mammals each year, including bats. Worldwide, they are responsible for the extinction of 33 bird species, and researchers have found at least 86 bat species preyed on by cats globally, a quarter of which are listed as near threatened or threatened by the IUCN. The minute your cuddly friend leaves your house, they become one of the biggest threats to local species, including bats. According to Bat Conservation International, all domestic cats that spend any amount of time outdoors, whether they are free-roaming house cats, stray, or feral, pose a threat to bats. Cats are carnivores, and it's in their nature to hunt. However, we've introduced cats to parts of the world that they never would have inhabited were it not for us, and the natural environment is suffering for it. So please, keep your feline friends inside. As for Bela and Boris, they were born on a farm in the country, but they will not be allowed to roam freely and slaughter local ecology, no matter how adorable you are. Pollution is the introduction of harmful material or energy into the environment. The two most important forms of pollution when it comes to bats are chemical and light pollution. Chemical pollution in the form of pesticides is a major threat to bats around the world. Insectivorous bats eat contaminated arthropods, and in some cases, entire colonies are sprayed directly in efforts to exterminate them. Even sublethal doses of pesticides can negatively harm bats, increasing metabolism, suppressing immunity, and affecting reproduction. Pesticide contamination has also been linked to bat mortality in cases of white nose syndrome by disrupting immune and endocrine function, thus making bats more vulnerable to the disease. Most of the research on the effects of pesticides on bats come from North America and look at organochlorides like DDT. While now banned in Canada, Mexico, the US, the EU, and Australia, the use of organochlorides remains widespread in Africa and parts of Asia. These compounds are notoriously persistent in the environment and accumulate in organisms over time. Studies in bats found the presence of these contaminants in tissues 20 to 30 years after it was banned. The effects of other common classes of insecticides like neonicotinoids and pyrethroids are largely unknown in bats, though they do negatively impact birds. Automobiles are another source of chemical pollution. Exhaust gases from cars pollute nearby areas and are associated with declines in arthropod diversity and abundance. A study found that lead and other metals from cars have significant effects on invertebrates up to 30 meters from roads. As previously mentioned, roadside hedges and trees are crucial foraging habitat for many bats. Declines in insects bats rely on could harm bats too. Broadly speaking, light pollution harms bats, though research on the subject mostly looks at insectivorous bats in temperate regions. Further, responses vary from species to species, with one paper describing it as a winners and losers situation. So let's look at the effects. Slow-flying bats that forage close to the ground appear to be the most light-averse. Members of the genus Myotis are only recorded away from streetlights, and Australia's chocolate wattled bat avoid parks when lights were on. Both high-pressure sodium and LED lights have been shown to discourage movement of bats, even when dimmed. This can result in fragmentation of foraging and roosting habitats for species. On the other hand, fast-flying species that forage in open areas are frequently found around streetlights. Lights that emit UV wavelengths, as well as mercury vapor lamps, attract insects and end up attracting the bats that eat insects. A concern for these species is that they will be drawn to illuminated places, like major roadways, and die in collisions. Technology makes addressing this problem easier than some of the other threats we've looked at. Turning off or dimming lights in green spaces during peak foraging time can help, as can motion sensors, directed and dimmed lighting. Making sure streetlights are designed to direct lighting downward onto streets and not up into the skies reduces excess pollution. We may also be able to use lighting strategically to protect bats by using certain types of lighting to deter bats from dangerous routes and redirect them to safer passageways, though more research is needed. Geologic events such as volcanic eruptions, earthquakes, and landslides are listed as a threat by the IUCN to 10 species. Though events like earthquakes and volcanoes are out of our control and thus not directly addressable by direct conservation, this threat demonstrates the vulnerability of small isolated populations and how threats compound one another. Several of the bats threatened by geologic events are found on islands, including the Ryukyu flying fox of the Ryukyu Islands, the Mariana fruit bat of Guam and the Northern Mariana Islands, and the Guadalupean big-eyed bat of Guadalupe and Montserrat. Island populations face many of the same threats as their mainland cousins, but the small size and isolation of islands amplify those threats. With small populations to begin with and with limited ranges, even relatively small losses can have devastating long-term consequences. The threats humans pose to bats and the losses suffered as a result reduce species' ability to adapt and cope not only to human intrusion, but natural disasters as well. When populations are already suffering from habitat loss, hunting, disease, pollution, or some combination thereof, a volcanic eruption may be a final pressure driving a species to extinction when previously they could have withstood a loss. Those are most of the major threats bat species around the world face, and some of the potential solutions. Clearly, we humans have a massive role to play in this. All but one of the major threats are caused by us. But we also have the ability to address these issues. Bat conservation organizations around the world are working to understand threats, protect species, conserve habitats, and educate people. Links to some of these organizations can be found in the description if you are interested in getting involved or donating. And many issues can be addressed on local and regional levels, including invasive species, wind energy, and even climate change. We have the tools to address many of these problems. It's a matter of implementation. The more voices advocating for change, the more we can change the world for the better, not only for bats, but ourselves too. That's all for today's video. If you watched all the way through, thank you so much. Let me know your favorite bat fact or species in the comments below. Don't forget to like and subscribe for more content like this. I make videos about sustainability, science, and human and natural history. Have a lovely night. Bye-bye!